All right, everyone. How is everyone doing? Um, okay, so uh, another quick recap. We've gone through the basics of networking. Um, I'm debating on whether I'm going to re-record those or not, or just leave them as there is. However, okay, on Udemy, my network basic course is a free course, so you can always go out there and look at that in a better, it's not going to be at this time frame a recording, okay, because as each time I do this, I get better and better, all right, or I should say more relaxed, more comfortable, and just different. It's the same, but it's kind of different, right? It's a different version of it. All right. So the information that you're going to get is going to be the same. Okay. Hang on for a second. All right. Cough is still there. I apologize. All right. Now, what we are going to learn today is the concepts of the beginning aspect of getting into a device or understanding the infrastructure or architecture or operating system of what we're going to be working on. And have no illusions. This is really the power and the skill set that you're going to be learning. Okay, you are going to be learning an operating system in pretty good detail. Okay, now, all right, whatever operating system you're using on your PC right now, mine is Windows 10. Okay, and the only operating systems since I have been working on or having a computer since 1994. Okay, is DOS 2.2. Okay, or was it DOS 6.22? Okay, that operating system. Okay, Windows 3.11. Okay, Windows 95, Windows 7, and Windows 10. Okay, those are the only operating. Oh, I'm sorry, and Windows XP. I'm sorry. Those are the only operating systems. Okay, that I have taken any efforts of getting to understand. Now, keep in mind, Windows 7 and Windows 10 is not something that I took time to understand, like I did with DOS, Windows 3.1, Windows XP, and Windows 95. Okay, all right. Those operating systems. I knew them like the back of my hand. Okay, meaning I can make some pretty cool. I can have my computer do some pretty awesome stuff. Okay, all right. I could go deep into the registry from memory. Okay, all right, to create D words or make changes in the registry, so on and so on. Okay, all right. Now, I don't need to get to an operating system level at that level anymore with Windows. Okay, as long as it does the basic stuff that I need to do. Okay, and let's be honest. Okay, play games. Now, with this field, okay, if you're a gamer like I was, okay, you're not going to be able to do both. From my perspective, I couldn't. I had to declassify myself as a gamer and give up my games to focus on my study. Okay, all right. I'm just now getting I'm just now getting back into gaming this year. That should tell you something. Okay, I declassified myself as a gamer back in 2009. Okay, all right. It was the hardest thing I had to do. Uninstall Steam, uninstall all my games. Okay, it was like pulling off a limb, but I had no choice. That's how bad I wanted it. Okay, so you got to ask yourself, what are you really learning here? All right, and what you're learning is an operating system, and you're going to learn this operating system because without software, hardware is pointless. Okay, all right, and the command line is where you're going to be spending all your time on. We don't do GUI, guys. Sorry, graphical user interface. We don't do that crap. Okay, you could be that person. Okay, all right, and go into the graphical user interface. However, if something is wrong and you don't know the command line, you don't know the operating system. Okay, all right. The GUI is not the operating system. Okay, now at one point, like Windows 3.11, that wasn't really the operating system. DOS was the operating system, and Windows was an application as a graphical user interface. Okay, if you want to look at it from that perspective. Now, like Windows 95, okay, because you would use DOS heavily in Windows 95. All right, but Windows 95 was a operating system. That user, that graphical user interface was the operating system. Okay, all right. So you looked at DOS as a application that was running on Windows 95. Okay, if you wanted to look at it like that. Okay, all right. Now, what separates one piece of equipment from another is software. Okay, great software will make a device function out of this world. Poor code, poor software, lots of bugs. Okay, don't get me wrong. Okay, Cisco's operating system, which is called Inter-Network Operating System (iOS), okay, and the CLI, which is the command line interface. Okay, there. I mean, it's buggy. Okay, now it's not like so buggy to the point where it's unfunctional, but every version will have some bugs in it. Okay, nothing's perfect, especially when it comes to coding and software. It's just too much. Okay, now have no illusions. Okay, if you have a PC background, okay, like a little techie, PC repair, so on and so on. Okay, these devices are nothing more than just a computer. Period. Okay, all right. They function like any other computer that does because it is a computer. Okay. However, using Cisco's operating system, okay, is a different type of computer because it's a different type of operating system. Operating systems or software makes the device. All right. So, just like any PC, we have RAM. Okay. All right. In memory. Okay. Whatever is stored in memory, right when you turn on the computer, boom. Okay. Things start coming from one device and starts loading it into RAM. Okay. Random access memory. Now, I'm not going to be spending a lot of time on these components, okay, but I'm going to tell you what they are and what they do, okay? You got some stuff on a hard drive that could be from a computer, okay? Yes, some of your routers will have hard drives or disks, depending on what they are, what model they are, and what platform they are, okay? All right, but they also have things that are stored in ROM. ROM is read-only memory. We can't write to it. Okay, we can manipulate it if we get to that level of access on the ROM chip, meaning then we would have to have a certain device that could read and edit that ROM chip. Okay, which you and I are never going to be, never go to that level. Okay, ever. All right, we're not going to do any soldering or anything like that. Okay, we would just get another router if it has to get to that point. All right, okay, so RAM gets loaded up with information right when you turn on the computer. Okay, it comes from ROM, gets stored over to memory, gets stored over to RAM, and it stays there as long as the machine is on. The second you turn off the power to that machine, whatever is in RAM is gone. Okay, it's gone. All right. Now, in RAM, this is where like your routing tables, your MAC address tables, your operating system is there. Your running config is there. Okay, and we're going to talk about the running config and the startup config as well. Okay, now, well, if the operating system isn't a ROM, where does it come from if it doesn't have a disk? Okay, because in order for the operating system to boot and be stored into RAM, it has to come from somewhere where it doesn't get deleted. Okay, because every time you turn it on from an off position, you're starting from scratch. Okay, that will be called NVRAM, non-volatile RAM, meaning that the non-volatile part means that it stays when the power goes off. It's still there. Okay, all right. Now, if the RAM stores your running config, okay, and that goes away, how do we get the running config not having to be reconfigured every time we reboot the device? And that's where the startup config comes into play. The startup config, okay, is stored in your NVRAM. Okay, and every time you boot it, your startup config gets stored into RAM, and that startup config becomes your running config. Whenever you make changes to your config live, you are making changes to the running config. If you want those configs to stay exactly like you have it now, you must save it to the startup config. Okay? All right? Now, instead of having disk, we have also what is called flash, which is permanent storage. Okay? All right? This is where you will actually load up your iOS. Okay? So, every time, that means if I'm going to boot my device, I'm going to pull the operating system, okay, and start loading it from flash. Okay, during that process, I start loading the operating system into RAM. Okay, and part of that process is to take the startup config from NVRAM and put it into RAM itself to make it a running config. Now, okay, you know, are you expected to know this? Absolutely. This is one of the things that I strongly suggest you to go read about, okay? Because the details on how this is done is always going to be explained much better in written context than I will ever be able to explain it. Okay, for two reasons. One, all right, my job with things like this is to get you comfortable with it and give you a better understanding. So when you go back and you read it, it's like, oh yeah, well, Kyle was saying something like that. Okay, not to go to the level of telling you every little teeny step all the way across the board. Okay, all right, that becomes boring. You don't retain the information, and you're gonna find that information like this. You got to go back and read it several times before it actually sticks. Okay, now from a exam perspective, yeah, you need to know this. As a engineer or beginning of your career being in this field, yeah, you need to know this. Okay, all right, and just like anything else, okay, what's in RAM is going to be your procedures or code to do your post routines. And if you don't know what post is, it's power on self test. Okay, you turn your computer on and you know what happens. There's a period of darkness on your monitor until that BIOS screen, the main screen, comes up doing your memory count, all that stuff. That means once you get that image on your screen, okay, the logo or whatever on your screen, you have successfully passed the post of your computer. If you never get to that screen, okay, the first screen that always pops up, you fail post and you don't get to go any further. Okay? All right, so now we know what RAM is, NVRAM, flash, and ROM. Now, ROM also holds another interesting thing that you need to know. Okay? And it's a mini, very particular basic iOS. And we call this ramen mode. And if you ever boot into ramen, you do not have a functioning device. Okay? You can actually force it to boot into ramen. Okay? And there's ways of um, getting say if you don't have if you don't have an operating system on Flash, it's going to boot into ramen. Okay, and in that mode, there is a way of getting it to boot and getting an image on it, being in ramen mode. But you got to be specific. Okay, all right. Your commands have to be specific because it's very, very basic. It is meant for you to bring it back to life, so to speak. Okay, so we understand what a starter config is. Okay, that is to bring your device back to the configurations that you have configured or engineered it to be. Okay, we know what our running config is. Okay, that's what stays in memory. Any changes that you make to that device live is in the running config. You must save it to the starter config in order to get it to boot exactly how it's working at the moment. You do not save that configuration on the reboot, okay, or power cycle, doesn't matter. It's going to go back and pull the starter config, okay, that you did not save, okay, meaning that if you made 15 changes that day and didn't save it, all those 15 changes on reboot or power cycle is gone, okay? And this could be years later, okay? It could be 5 years later, okay, before this thing reboots, okay? Unlike Windows, okay, we don't have to reboot on every change we make, okay? And the longest I have seen, and I'm not kidding, the longest I've seen, okay, a device in uptime is 10 years. All right, I've never seen anyone higher than that, but think about that. Okay, you do a simple command that says show version, and it's going to tell you how long this device has been up. And when you see 10 years on that, you're like, wow. Okay, all right. Okay, your config.txt. Okay, that's where it's stored in. Okay, all right. Now, in order to access your device, you have two things: an auxiliary port and a console port. Now, the console port is what you need on a regular basis to access a device. Okay, you can access a device with another device using the auxiliary port, which is called reverse telnet. Okay, and you would need your pins of your cabling, because you got 8 of them, all right, have to be reversed. One side has pin 1 on the left, the other side has pin 1 pin 1 on the right. Okay, you're reversing the order of the cables. It's called a rollover cable. Okay, and plugging it into the working device that's working into the auxiliary port, and plugging it into the console port that you're trying to console into, okay, you can actually telnet to the device that you are working on, that's working, okay, and it will send the information through the auxiliary port over to the console port, giving you access. That's why we call it reverse telnet, because you're actually doing the telnet on the device. You're not telnetting to the device you're trying to access. You're telnetting to the device you're on, hooked up to the auxiliary port, and then you can go through the console port of the other one. And it is awesome as hell. And I have used this thousands of times. Okay? This, just that knowledge in itself could save you so much grief in so many scenarios. Okay? Because you can't get the device, the person doesn't have this, doesn't have that, whatever. All right? Okay? Now, so more than one way to skin a cat. Okay? I'm gonna leave the I'm gonna leave the information just like that, this video just like that, and leave it as a beginning aspect of it. Okay? All right, and then we will go into the next. I'm actually looking at this. Why is this here? I think this was for something else. Oh yeah. Okay. All right. So I guess this is where we're going to next. Okay. All right, guys. So I will see you on the next one.